This video is going to cover the material in section 11.2, which is about the quadratic formula. And so what we're going to do basically is learn how to solve quadratic equations using the quadratic formula. And we'll also talk a little bit about approximating solutions to quadratic equations. So when we solve by completing the square, we know that the procedure is the same. And when it's repeated many, many times, we can actually often find a formula to speed up the work. And we actually get the quadratic equation out of the quadratic formula out of completing the square. So here is the quadratic formula. You have to have your equation in the form ax squared plus bx plus c equals 0. And there has to be a squared term. That's what a cannot be equal 0 means. So again, everything on one side, 0 on the other. And then the coefficients a, b, and c are what get plugged into the formula. And the formula is given by x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. Or you can learn it to Mary Had a Little Lamb, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to solve this equation using the quadratic formula. So first we have to determine a, b, and c, but it's not even in the right form yet. So we have to move that 2 over to the other side. So we have 0, so we can get the right sign on c. So a is the coefficient of the squared term, so it's 3. B is the coefficient of the linear term, so it's 5. And c is the constant, which is -2. And then we just plug it in. So since b is 5, we want the opposite of b, so minus 5. Plus or minus 5 squared minus 4 times 3 times -2 over 2 times 3. And then it's just a bunch of arithmetic from here. So we'll end up with -5 plus or minus the square root of 49 over 6. Square root of 49 is 7. So it's -5 plus or minus 7 over 6. You do both sides of it, and you end up with 2 over 6, or -12 over 6, which reduces to 1/3, or -2. And you check those by putting those into the original equation before you move that constant term to the other side. Always check these. So overall, if you're going to solve a quadratic equation, you're hoping that you can just use principle of square roots. So you can really easily write it in a form where you can use principle of square roots. But if you can't, then you want to put it in the form ax squared plus bx plus c equals 0. And you want to see if you can use the principle of zero products. For something that's easy to factor, that's the easiest way to do it. But if that's difficult or impossible, or you just don't see it, use the quadratic formula. It always works. But you can't always use factoring, but you can always use the quadratic equation, and you can always use completing the square. So this one, we're going to use the quadratic formula again, but this time we have our linear term on the wrong side. So we have to move that over as a -2x first. So now a is 1, b is -2, and c is 7. And if we put it into the formula, the opposite of -2 is +2, plus or minus -2 squared. Make sure you put that in parentheses so you know that that's going to end up positive. Minus 4 times 1 times 7, all over 2 times 1. So we've just substituted in, and now we do the arithmetic. We end up with 2 plus or minus the square root of 4 minus 24. Or minus 28, which is -24. So we have a negative square root here, which means our roots are imaginary. are going to be complex numbers. 2 plus or minus 2 times the square root of 6i. Now we need to reduce as far as possible, and every term has a 2 in it. So we'll take that 2 out, and we'll get 1 plus or minus the square root of 6i. You can also write I times the square root of 6, just so you make sure you're aware that the I is not under the square root sign, because as you can see here, it's really hard to tell. So the solutions are 1 plus the square root of 6 times I and 1 minus the square root of 6 times I. And again, you want to check those in the original equation that you were given.